Hello, grade 11s. We are still on mechanics, vectors in 2 dimensions. Now we are on video number 2. We are going to calculate the magnitude of the resultant using theorem of Pythagoras. And also we determine the direction of the resultant using trigonometric ratios. Okay. The definition that we have here, there are many definitions. That is vector, resultant, but the resultant is the vector sum of two or more vectors. That is a single vector having the same effect as two or more vectors together. So which means we are combining vectors here. Okay, so we are going to use theorem of Pythagoras. That is r squared is equal to x squared plus y squared. So we are looking for resultant, which means if we are talking about a force, it will be F res square, which is equal to Fx square plus Fy square. This is horizontal force, this is vertical force. Okay. Then we are going to calculate the direction. We are going to use a 1-trig ratio, that is tan theta, which is equal to opposite side over adjacent side. Think of the triangle, that is the right-angled triangle. It has r here, it has y here, it has x here. Okay, then this is our angle theta. So this angle theta is telling us about the steepness of this line. This is the angle of inclination. It tells us the direction of this line. Okay, but we're not there. All right. So the direction we're talking about is that theta. How? We are using the compass. So the compass is like this. Okay, so we know that this one is upwards. Let me just say up. This one is right. This one is downwards, down. Then this one is left. Okay, but what about this? This one is between up and the right. So what we need to know is the direction of this line. So we'll know the direction of this line by this angle. Okay, we'll know the direction of this line by this angle. We'll know the direction of this one by this angle. We'll know the direction of this one by this one. Okay, so we use the compass. The compass we have north, south, east, west. Okay, which means this one, if we are talking about this angle is above east, which means this angle is above east, is the north of what? Of east. This one is above west, so is the north of what? Of west. This one is below bani east, which means it's the south of what? Of west. This one is below east, is south of what? Of east. Okay, then we are looking for this angle. That is why we are going to use tan theta. Okay, we are looking for that angle. So we are going to follow some steps here. Number one, the first thing that you need to do is to look at horizontal forces. Then you look for the resultant of horizontal forces. You combine all the x forces on the x-axis. Okay, Then number 2, you also combine all the y forces, so you will have only 2 forces. Then these forces, you are going to represent them on a Cartesian plane. Then we sketch x and y. Then after that x and y, okay, after that x and y, we use Pythagoras theorem. We use Pythagoras theorem. R squared is equal to x squared plus y squared. After that, we use tan theta to get the direction. So we use tan theta to get the direction. Tan theta is opposite over hypotenuse or adjacent. Sorry for that. Then we are done. Okay, step number 1, you combine your x. Number 2, you sketch. Then 3, Pythagoras. 4, we use tan theta. These are our steps to get the resultant, okay, with the direction. Remember, now we have this example that we used in the previous example. Okay, so they said draw the following forces as vectors on a Cartesian plane. Luckily, we have only 2 forces here, and these forces is force 1, that is x, and force 2, that is y. So this one is very easy. Remember, step number 1, you must know your total force x. In this case, our total x is 1,5 newtons. Then our total force y is just 2 newtons. This one is in the positive x-axis. We can just say right. This one in the positive y-axis. We can just say upwards. Right? Then step number 2, we sketch. Step number 2, sketch. So let's sketch this one. So we have the Cartesian plane. In this case, we have positive and positive. So I'll just focus on positive and positive. This is y. This is x. So we have 0 here. 1, 2, 3. 1, 2, 3. 1, 2, 3. Okay. So let's represent this on a Cartesian plane. So we have x, which is 1,5 to the right. 1,5 to the right. This is 1,5 to the right. So this is force number 1, which is 1,5 newtons. Then we have y, which is 2. That is F2 is 2 newtons. Now we need the resultant force. We need the resultant force. Okay, let me just write it here. F2 is equal to 2 newtons, this one. So we need the resultant force. If you are pulling the object in this direction and someone is pulling the object in this direction, the object will move in this direction. Ekugqibeleni izomove in this direction, right? So we can combine and have what? A triangle here, a right-angled triangle. A right-angled triangle. Okay, we have the right-angled triangle. Remember, this is y, and this one is y. So this is our F2, which is equal to 2 newtons. Okay, so with this triangle, then this is the angle we are talking about. This line is above x-axis. So if we can go back to the compass, this line is in this direction. Okay, forget to put the arrows here because we're talking about the direction. So we're talking about north of east. Yeah, so the resultant force here is directed on the north of what? Of east. This is F-res. Okay, so we're looking for F-res. So step number 3, use Pythagoras theorem. So r squared is equal to x squared plus y squared. So our r squared is F-res square, which is equal to our x, this is our x, 1,5 square, plus our y, this is our y, it's 2 newtons. F-res square is equal to, press calculate. So the answer is 6,25, then the square root. So F-res is equal to 2,5 newtons. Okay, now we need the angle. At which angle? Because we need this theta here. So we are going to use now, we need the angle here, but we know that north of what? North of east. We need theta here. Now let's calculate theta. That is step number 4. Tan theta is opposite over adjacent. Okay, so tan theta is the opposite. This is theta, this is opposite to theta, which means it's 2 over the adjacent is this one, 1,5. Okay, then to solve theta, we say theta now is equal to tan inverse of 2 over 1,5. Then we get theta. Then you have theta, that is your direction. So you can just put here. Therefore, F-res is equal to 2,5 newtons at angle 53,13 degrees north of east. Then we are done with this one. Let's go to another example following the steps. Example number 2, draw the following forces, but we calculate the resultant vector using these forces, right? So the first thing that we do is to combine. Step number 1, determine Rx and Ry. So here we have 2 axes here, 2 forces that are horizontal. So let's combine them. Take right as positive, right as positive. So this one is positive, that is right. This one is negative, no problem. So Rx, or let's just say Fx to make it easier. So Fx, because we're talking about the forces, is equal to 3, which is positive, minus 3 minus 1. Therefore the answer is 2 or positive newtons, which means 2 to the right. Perfect. Then let's look at Fy. F3 is our Fy. only Fy and is positive, so it's 3 newtons upwards. Now step number 2, we are going to represent this information on a Cartesian plane. Okay, we are going to represent this information on a Cartesian plane. So we draw the Cartesian plane. We have positive, positive, so the focus is on positive x and positive y. So we have 1, 2, 3. 1, 2, 3. 1, 2, 3. Positive 1, positive 2, positive 3. Here is 0. Okay. Now let's represent this information on this graph. So we have x, which is 2 units. So this is x 2 units. That is fx. Okay, which is equal to 2 newtons, I mean. Then we have y, which is 3 newtons. 1, 2, 3. This is 3. That is fy, which is equal to 3 newtons. Okay, so this is very simple. So if you pull this up and to the right, therefore it will move in this direction. Okay, it will move in that direction. Now let's try to make a triangle. So we have this one. So the angle is above x-axis because these are x-axis, these are y-axis. The angle is above, which means this one is north of what? Of east, above. So this one is these dotted lines. So this is our Fy, which is equal to 3 newtons up. Then this line represents Fres. Always write that Fres. Represent the Fres. Okay. So what we are going to do is to go to step number 3, Pythagoras theorem. That is x squared. Oh, it's not x squared. We started with r squared. In our case, r squared is equal to x squared plus y squared. So our r squared is Fres square. Our x now is 2. Our y is 3. So Fres square is equal to 2 square 4, 9. 4 plus 9, this is 9, this is 4. 4 plus 9 is 13. Then we put the square root, then Fres is equal to square root of 13, which is 3,60 newtons. We need the angle, but north of east. We need theta. Then we go to step number 4, where we use tan theta is equal to opposite over adjacent. Okay, to get the direction, that is theta. So tan theta is equal to the opposite of this one is 3 over, then the adjacent is 2. Okay, theta is equal to tan inverse of 3 over 2. Theta is equal to tan inverse of 3 over 2 is 56,30 degrees. Therefore, the net force or the resultant force Fres is equal to 3,60 newtons at this angle, that is 56,30 degrees north of east. Okay, then we are done. So another way of representing this data is to use the tail to head method. We are going to have a video for tail to head method. We'll have a triangle of tail to head method. Then we calculate whatever. Okay, thank you.